Okay, Math 8 students, this is lesson 6.2, describing functions. We are building off of our lesson 6.1 where we were identifying functions. Now, we're going to determine what characteristics of functions that we are looking at. Are they linear and proportional, or are they not linear? And this builds off of a lot of what we've known with our equations, y equals mx plus b, our slope-intercept form, and our graph stuff. So a lot of this is review. We're just building it into the new concept of functions. So the first thing that we're going to do is we're going to take a look at a linear function versus a nonlinear function. And then within that, we'll talk about what is proportional and what is not. Because when we looked at linear proportional relationships, all we did was look for a y-intercept, which is all we'll be doing when we look at linear relationships as well. Okay, so let's jump right in. If we have a linear function and we're looking at an equation, well, the first thing we want to notice is that it can be written in y equals mx plus b form. Okay, so that's our slope-intercept form, and that means that this is our slope, which means it has a constant rate of change, and this is our y-intercept. So m is a constant rate of change, which means it's going to be a straight line. B is our y-intercept, which means it will be a straight line, but not proportional. So if it's in y equals mx plus b form, and it has a y-intercept, it is linear, but not proportional. If it is just y equals mx, then it is linear and proportional. Okay, so this equation right here, if we look at this is our y equals, and here is our mx, so our slope, and this would be our b. Okay, so it's not in the exact same format, but it is still y equals mx plus b, where we have our y-intercept and our slope. So this would be linear, but also non-proportional, because it has a y-intercept right here, which means it's not going to go through the origin. Okay, so as opposed to an equation that cannot be written in y equals mx plus b form. So this equation right here is y equals, and this is our slope, but it's not a slope. This is an equation. So anytime that you have an exponent, that's going to give you a curved line. Exponents will never be not equal to linear. Exponents will never be linear. So if you have an exponent in your equation, it's not y equals mx plus b. It is a nonlinear equation. And so, if it's a nonlinear equation, it's a nonlinear function. So we're going to go ahead and move on down here to tables, and we're going to use the same equation here. So we already know that it's linear, but we're going to see what that's going to look like in a table. And that means it's going to have a constant rate of change. So if this is our rate of change right here, we've got a -2. We're just going to double check that here in our table to make sure we know what it looks like in a table. So I'm going to go ahead and plug my x values in to my table to find my y values. So plugging in my input, getting my output. My first one here is -1, so I have y equals, and I'm going to just put this into mx plus b order, so I'm going to go -2x, because I'm taking that negative sign, plus 5. I'm going to put my x value in, my first one, so I have y equals -2 times -1 plus 5. Y equals 2, because a negative times a negative is a positive, plus 5 equals 7. So y equals 7 here. So when x is -1, y is 7. And I'll go ahead and do the next one here, where I've got y equals -2, and my next x value is 1 plus 5. So I've got y equals -2 plus 5, which equals 3. So when x is 1, y is 3. And I'm going to go ahead and just plug my next two y values, and y equals -2 times 3 plus 5. This is -6 plus 5. So that equals -1. So when x is 3, y is negative 1. And then my last one that I'm going to plug in here is y equals negative 2 times 5. That's my remaining value on the table. Plus 5. So y equals negative 2 times 5 is negative 10. Plus 5 is negative 5. So now I'm just going to show you what it looks like for a table to have a constant rate of change. And this is all review. Like we've found this with tables before, but we're just connecting the concept to functions. So my rate of change for x is this is a plus 2, plus 2, plus 2. So my change in x is plus 2. And then I'm going to look at here, which is a minus 4, minus 4, minus 4. So my change in y is minus 4. Now remember slope, I've got to flip-flop those because I need change in y over change in x. So I've got negative 4 over 2, which is negative 2 over 1, or just negative 2. Right? So that's my slope. So I have a constant rate of change. And we actually already knew this because it's right here in our equation. But now we know what it looks like in a table. Notice I've got a constant rate of change. Constant rate of change. As opposed to if I have this table here, which represents a nonlinear function. I'm going to plug in my values to my equation y equals, and I'm not going to rearrange it because I don't need to, y equals 2 minus x squared. So if x is negative 2, negative 2 squared, so negative 2 times negative 2 is 4. So I've got y equals 2 minus 4, which is negative 2. So when this is negative 2, when x is negative 2, y is negative 2. When my input is negative 2, my output is negative 2. Let's plug in our next one. Y equals negative 2 minus negative 1 squared, because I'm just plugging in my x. Negative 1 times negative 1 is positive 1. So I've got y equals 2 minus 1, which is 1. So this is when x is negative 1, y is positive 1. I'm going to plug in my, oops, this is in the way here. Move this right here for now. My 0, so I've got y equals 2 minus 0 squared. 0 times 0 is 0, so y equals 2 minus 0, which is 2. Next one, y equals 2 minus 1 squared, because that's my x value. X is 1. 1 times 1 is 1, so y equals 2 minus 1, which is 1. And then my last one, y equals 2 minus 2 squared. 2 times 2 is 4. So I've got y equals 2 minus 4, which is negative 2. Okay, so I want you to look at this table here, and we don't even have to find our rate of change. I see that I've got input values, and my output values repeat, right? So I've got repeating output values here, which means that this is not going to be a straight line. If it's not a straight line, then it is a nonlinear function. It can still be a function, as long as it passes the vertical line test, and each input has only one output, which is true. That is true in this. However, it does not have a constant rate of change, right, if this is plus 1 the whole way. But this is plus 3, plus 1, minus 1, minus 3, right? So it does not have a constant rate of change. It will not make a straight line. It is a non-linear function. It is a function, but it is non-linear. So I'm going to go ahead and we're going to graph these now to show what these look like as graphs. So we've got an equation here that we're going to graph, and I'm going to just graph the example that we have up here. So it's the same as the equation we had, and from this table, this gives us our ordered pairs. So I'm just going to use those ordered pairs to graph, and I'm just going to write them over here. So I've got x is negative 1, y is 7. I'm just pulling that from the table. Then I've got 1 and 3, 3 and negative 1, and 5 and negative 5. Okay, so my first point here is negative 1 on the x and 7 on the y. And I've got +1 and +3. Then I've got +3 and -1. And then I've got 5 and 5. So 5 and -5. So we can see that the equation, the table, and the graph all prove that this is a linear function. It is a straight line. It doesn't go through the origin, so it's non-proportional, but it is a linear function because each input value has only one output, but it is non-proportional. So it's a non-proportional linear function. And then I'm just going to give you another example here, and it doesn't have any points attached to it, but if I had a graph that looked like this, goes through the origin, it's a straight line, right? So it is linear. And if it's a linear equation, it is also a linear function. And in this case, it goes to the origin, so it is a linear and proportional function. In the equation would be in this form y equals mx. It wouldn't be y equals mx plus b, but it would be y equals mx. And the table would also show a constant rate of change. Now, let's go ahead and take a look at the graph of a nonlinear function. And we're going to take the points from the table above. So I'm just going to slide that up here so we can write them over here on the side. And so my x value is 2, my y value is -2. I'm going to write them over here. I've got -2x, -2y. Then I've got -1 and +1. Got 0 and 2, 1 and 1, and 2 and -2. Okay, so, and remember I got these points from the table, and I got those table values from my equation. So I got the equation, I got the table, and now I've got the graph. So let's go ahead and graph these. And I've got, so x is -2, y is -2 for the first point. Then x is -1, y is +1. Then we've got 0 and 2, then 1 and 1, and then 2 and -2. So if you look at this, what you're going to see is this makes a parabola, okay? So this is obviously not linear because it's not a straight line, but is it a function? Yes, it is a function. It does pass the vertical line test, okay? If we were to draw a line, a vertical line through any of these, it's only crossing one point, so each input has only one output. So it is a function, but it is not a linear function. So it is a function, but it is not linear. And so that's what you guys are doing today, is you are identifying, or doing in this lesson, is you are identifying functions, if they are linear or nonlinear, and if they are proportional or non-proportional. Now, if they are not linear, they can't be proportional, so you've already ruled that out. I don't even have to look at this one and say that it is not proportional, because it's not. It could have gone through 0.00, but it being a curve, it tells me that it's not linear, and if it's not linear, it's not proportional. So keep that in mind. And hey, bonus, you guys made it to the end of the video, and now you get to know that what we just did for notes is the first two questions of your corresponding assignment. So the assignment that goes along with this lesson, the first two questions, these are them. They are already done for you. Okay, so I'm going to post a second video after this. It is the back side of the notes. It is this page. It says your turn on it, and it is just some extra practice if you want to do some more work on investigating constant rate of change and determining if things are linear or nonlinear functions. Then you can go ahead and do that. Otherwise, you are done with notes. Bonus activity is just extra practice. You can do it with or without the video. That is up to you. Okay? I will see you guys on the flip side.